Hi everyone, welcome to Python Osmosis, episode 42, the screencast that dips its toe in the cool and refreshing pool that is the Python standard library. I'm Ryan Shea, and in this episode we'll be talking about more on the standard library. I've already gone through some of the standard library, but let's press on. Dates and times is something that you end up working with quite a little bit in programming, so let's, from datetime is the module that you'll commonly use, import date. Let's make a datetime object. Now equals date.today. Okay, and if you look, that'll actually show us a representation of what today's date is. But there's more information that's in that datetime object. There's strf time. You can see it's going to print out a formatted string of the actual datetime object. So we can do now dot strf time. I'll copy and paste this into here so you can get an idea of the month, the day, the year. If you're familiar with string time formatting, this is going to be something you're used to. But you see, returned back was a string. That was exactly what we wanted. Also in datetime we have some basic arithmetic. So let's make birthday equals date 1976 12/17. Alright, that's my birthday. And age equals now minus birthday. And now you see we have this datetime object, and it's a datetime.timeDelta object. So if I said age.days, that's the number of days. So I could divide that by 365.25 and figure out how old I am in years. All right, let's move on into data compression. So there's a bunch of compression modules that are in the standard library. There's zlib, there's a gzip, a bz2, zip file, and tar file. We're going to take a look at zlib real quick. So let's just pull that right into our namespace. We're going to make a string that may be compressible. Let's take a look. Which has which is wrist watch. Little tongue twister there. And let's look at how long that string is. It's 41 characters. And let's make a new zlib object, and we're going to compress zlib.compress. We're just going to do the standard zlib compression, zip it basically, into another string. And if you look at T, there's the string representation of that. And if we looked at the length of the newly compressed version, it's 37 versus 41. So we got a little bit of optimization there. And in order to uncompress it, you just say zlib.decompress on T. Again, with IPython, you can always just zlib dot, and you can tab to see what's included in there. So we have a CRC32, we have compress, we have decompress, which we just used. Let's do the CRC32. And that is exactly what it sounds like. It's a CRC32 cyclical redundancy check on that actual string, and there's our CRC number that comes back. Something you might find as you're learning Python, you're not necessarily sure what the fastest way to do something is. Performance measuring is something that's built right into the Python standard library, and one of the modules that you'll see commonly is called timeit. So let's pull that in from timeit import timer. Okay, and in this example, I'll take a look at swapping around some variables. So we're going to create a timer object. Timer is the module within the timeit package. So let's do this. Okay, so the first thing that we pass when we create this this class instance is the actual code that we're going to use, and then we pass it some initialization code. So we start out, we say a equals 1 and b equals 2. We want to swap those around. So we make a temp variable a, set that equal to a. We make a equal b, and we make b equal the temp. That swaps around those two variables. How long does that take? Well, this gives us really high resolution of how long that takes. Now, what if we wanted to do that a little bit of a different way with packing and unpacking tuples? Let's do the same thing. Okay, and this is just, on the right side here is packing a tuple, on the left side is unpacking a tuple, and that just swaps it around. Which one is actually faster? It looks like the tuple version is faster, 0.15 seconds. So that's a pretty useful way to just do quick and dirty tests to see if something is faster. Now, one of the coolest modules, I think, is something called doctest. We've talked about docstrings, but doctest is a way of putting unit tests right into your documentation. It also, as a side effect, makes your modules more readable by putting an example into the unit test. So let's take a look. Actually, I'll hop out of IPython for this and go into the regular Python shell, just because I'm going to show you how you can take the output on the standard Python shell and put that right into your docstring. So we're going to make a function called average, and it's going to do just what you think. It's going to average some numbers, but I'm going to copy into here a docstring. Okay, so pasted right into here with our triple quotes, computes the arithmetic mean of a list of numbers, put a white space, and then basically what doctest will do is it looks for things that look like they're outputs from the Python shell. In this case, you have the 3 greater than signs, and it's using this actual definition. Print, average, and then it sends in a list values. So now let's actually have what this function will do. Simple, return sum of that list that you sent into it, 0.0, divided by the length of what you sent into it. So that's a basic average. Normally the way that you do this is in your if underscore underscore name underscore underscore equals equals underscore underscore main underscore underscore, right? That's you normally would have a module that you're typically including. You're importing it into other scripts. Now if you run it directly, you'll just have the standard thing to do is to run doctest, and that'll run your unit test simply by executing the module. But let's see. So you import doctest, and then you just do doctest.testmod. It's going to run through the whole module looking for these doc tests. In this case, it's actually going to expect back that 40 is returned from the average of 20, 30, 70. So let's take a look. Cool. It failed none, it attempted 1. Now, if I redid this, a good way of creating these is to put in your unit tests and then make sure that it fails so that you're confident that when you get your string back and there's a mistake that it'll barf at you. So 30.0. So 20, 30, and 70, we're saying that we expect that to be 30.0, which of course it isn't. And then we'll do the same thing here. So now you see you get a failure. Test failed, 1 failure, 1 attempted, 1 failed. Pretty cool. So if you ever make a mistake, you'll immediately find it just by running the module. Very, very cool. There is another more comprehensive way of doing unit tests called the unit test module. Now I haven't done too much work with this, but I'm going to show you an example real quick where you can create a class for your unit tests, and you can have those all kind of in a separate file. So here is an example. You import unit test, and then you create this class, test statistical functions, and in here is our test average, and you see each of these, there's a round, an average, a zero division error, type error. So you can do a lot more comprehensive testing. The doc test is more of a quick and dirty, but it's very powerful because it's so easy that you'll actually use it. As soon as you know your unit tests are going to get more complex, definitely explore using unit test. Just want to say a couple other notes. There's a lot of other modules that you might want to take a look at. Use IPython, look at the documentation, look at the help. There's things for XML RPClib, simple XML RPC servers, there's email, there's parsing DOMs, there's CSV modules, text modules, codecs, locales. There's all kinds of things that are in the standard library that are part of that batteries included philosophy. That's all for now. This screencast is directly inspired by the official Python tutorial by Guido van Rossum at python.org.